Hi guys, today we're going to learn how to solve a system of equations using algebra. Yesterday what you did was using graphing. So here we go. When we are solving a system of equations, you know what equations look like. There is a variable and equal signs. A system is two or more equations. And when we are solving a system, we're looking for an ordered pair. And there are three ways to solve a system. One is by graphing, by substitution, and by elimination. So today we're going to do substitution. So let's solve a system using substitution. These sample problems are from your textbook. So there are two equations given, and y is equal to 3x and x plus y is equal to negative 32. The goal is to take these two equations and create one equation with one variable. So if you look at this, it says that y is equal to 3x. So something that we can do is take this 3x and substitute for the y in the second equation. So it turns out that we're going to substitute for y, so x plus 3x is equal to negative 32, and then you solve, x is equal to negative 8. And now you can take this new x value and plug it into any one of these equations. You want to choose the equation that is easiest to work with. That means it has the least amount of negatives and fractions in it. So I'm going to choose y is equal to 3x. I'm going to substitute my x value that I just found, and the answer is y is equal to negative 24. In your notebook, you are going to create two columns of work, just the way I have it on this slide. And then finally, you're going to write that the point of intersection is negative 8 and negative 4. Something like this earns you full credit for the question. Let's try another one. Actually, you try this one, pause the video, and then I'll speak. So here we have y is equal to 2x plus 7 and y is also equal to x minus 1. Since both of these are y's, they must be equal to each other. So 2x plus 7 is equal to x minus 1. Simplify, solve, plug it into whichever equation you want. I chose the second one because it's simpler. And then solve for y and write your answer with the x and y value that you just found. So we're going to try something a little bit more complicated. In this, we have two equations and it looks complicated, but remember, you want to find some way to substitute, and you try to look for the variable that is already by itself. And I'm looking at the y, and y is already by itself in the second equation. So I'm going to take my second equation and isolate the y. And since I used the second equation to isolate the y, I am going to plug this y into the first equation. So I take the first equation from the top, and this y that I just found, I am going to substitute into 3 times y. So I get 3 times 2x minus 3. I now have one equation with one variable, so I can solve it. And don't be afraid if you get fractions or decimals, they are numbers too. And now I'm going to use this x is equal to 2.3 in any of these two equations. I like the second equation, it looks simpler to me. So I'm going to substitute, solve for y, and my point of intersection is 2.3 comma 1.6. Try this by yourself. Try to look for a variable that you can easily isolate. You may want to pause the video and give it a try. Here we go. Turns out that I can use my second equation to isolate just the x, and x is negative 3y minus 7. I'm now going to use that in the other equation. Remember, you have to use it in the other equation, otherwise you will end up getting no answer. And so I plug it in for this x, and now I have one equation with one variable that I can solve, and I get a fraction, and my fraction is negative 43 over 9. So now I'm going to go back and plug in this y value into any one of these equations. I think the second equation is the best choice. And in fact, I already know that x is equal to negative 3y minus 7. So I can plug it in and simplify. And my answer turns out to be 22 over 3. Now notice we found y first and then x, and that's okay. However, when we are writing ordered pairs, you cannot leave your answer as improper fractions because these are points that need to be plotted. So you're going to convert to a mixed number, and the answer is 7 and 1/3 and negative 4 7 over 9. Let's try this one. Here, x is already isolated in the first equation, so we're going to use that x value in the second equation to create one equation with one variable and then simplify. And here it turns out that the y's cancel out and we get 14 is equal to 14. If you end up with a statement that really is not solving your equation, but it's true, then this is when the two lines are identical. And the answer is infinite number of solutions. So remember, if you get a true statement, it's infinite solutions. And here, y is already isolated, so in the first equation, so we're going to plug it into the second equation. And when you solve this, you get a statement that is false. So this is the opposite. This one has no solution because these are parallel lines. So the answer is there are no solution. There is no solution rather. And that is it for today. And I'll see you in class. Goodbye.